Okay, here's a video on congruent triangles. Now, when we're talking about congruent triangles, we're talking about two triangles that are exactly alike. They have the same lengths on the sides and the same three angles. There's four shortcuts or theorems, four ways that we can prove that two triangles are equal. One way is side, 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 and what that means is if one triangle has three sides and another triangle has three sides that are just exactly like it, they're marked equal to each other, then those two triangles are congruent. We're going to mark those like side, side, side. If they have three sides that are the same, then the two triangles are exactly alike. Another one is if they have a side, an angle, and a side in exactly that order. See how that goes side, angle, side? And this one has side, angle, side marked the same. If two triangles have that marked, they have a side, an angle, and a side that are alike, then the two triangles are congruent. Notice they don't have to be in the same direction. So that's the second one. If they have angle, side, angle, they have an angle, side, and an angle, angle, side, angle. If they have that in common, then they are congruent. And the last one is angle, angle, side, angle, angle, side. See how it's in order? Angle, angle, side. They have that the same. They have that, then the two triangles are congruent. Now let me show you how all this works. I've got several examples here that you can look at. Okay, for this one, we have a statement saying that if AEC, that's triangle AEC, is congruent to triangle GED, then you got to look at these letters and you got to do things in the same order. Like this says which angle is congruent to angle C. C is the third letter, so B, angle D, is what's congruent to it. Here we have side AE. Now look, we got AE. Over here in the same place is GE. See how you got to go in order? GE. Alright, here we have GD. So the third one and then the first one and then the third one. So I'll do the same here. First one and third one. What's the same? AC. And then the last one says angle E. One in the middle. It's the same as angle E in the other one. One in the middle. See how this works? Alright, this says mark the triangle to show that triangle QRS is congruent to triangle LMT by the SAS postulate. That means side, angle, side. So I'm on my QR. Now look, watch this. QR is here. It's got to be LM. LM is here. Now even though these triangles are sitting in this position, watch how these sides work. Then it says angle R is the same as angle M. See how it's side, angle, side? So now I'm going to go this angle, angle R. But look, angle M is here. Be careful. A lot of mistakes. A lot of people would have put it here. That's why you got to go by these letters. And then if it's side, angle, side, side, angle, side, we got RS. MT is the side that's the same as RS. So it would be marked like this. See how that works? Okay, it says what additional information is necessary to prove that ABC, triangle ABC is congruent to triangle DEF by AAS? Well, let's see, A, so we got angle A, or B and E, we could have C and F, so A, C and F are the same. Now it would be AAS, angle, angle, side, AAS. Alright, this says which is true, and we have these different triangles marked. We got to see which one's letters are true. Let's just check them one at a time. This first one says A and Q are the same. Well, A has one mark, Q doesn't. We can eliminate that one right off the bat. B says A and P are the same. See that? A's got one, P does not. We can eliminate that one. This says A and R, that's true. B and Q, that's true. C and P, that's true. So that would have been the answer. So you have to check the letters, making sure they line up. All right, this says, which of the following can prove that ZXY is congruent to RPQ? Well, let's look what we got marked here. We have an angle, side, and an angle. Angle, side, angle. So these are pretty easy. They're marked for you. Angle, side, angle. Alright, this says in this figure AB is congruent to CB. If you ever get that, you can mark it. AB is congruent to CB. And DA and DC are congruent. We also know that they share this line, so technically this line's congruent. Alright, so I'm just going to write this out. I'm going to start with B, and I'm going to go ahead and triangle B, A, D, bad, would be congruent to triangle B, C, D. See that? See how I went across that 1 and then across the 2? I got to do that down here as well. So B, C, D. Now I can look at our choices and see which one is true. I should have B lining up with B. I have B lining up with B here. I should have A and C. I have A and C, and then you have D and D lining up. D and D lining up. See how they all line up together? You can check all the other ones. All of them would have to be true. Here's the only one where they all are true. Alright, this says, suppose triangle XYZ is congruent to LMP. If Y is 96 and L is 48, what's the measure of Z? What's the best way to do this? Okay, let's draw two triangles. We got X, Y, Z. This one. Now it said that it is congruent to LMP, so you got to go in the same order. LMP. Now it says Y is 96. So this is 96. L, right here, is 48. Well, if L is 48, then X is 48, since they're congruent. The question was, how much is Z? Well, from our study of triangles, we know that if I take 180, subtract 96, subtract 48, what do I get? Well, let's see here. 180 minus 96 minus 48 equals 36. So that would be the answer. Z would be 36. Consequently, this would be 36 and this would be 96, but it's not asking that. Alright, this says triangle BOA is congruent to what triangle over here? Alright, look at this. They share this line. BOA went across 3 and then 1. So this one's tricky. Over here, how do I go across 3 and then 1? I do it this way. I go across 3 and then 1. So BOA is congruent to OBM. And then I got side, side, side. I have 3 sides marked for each of them. You got to be really careful with these. When I said BOA, look, I went across the 3 first, and then that 1. That 3 and that 1. So on this one, I gotta go across 3 and 1. that bell. Alright, this one, KAZ, KAZ is congruent to which one over here? Look, I went across the arrow and then the 1. Over here, we got to do the arrow, then the 1. So this is ORZ. Now, the shortcut, I have vertical angles right here, so we know these angles are equal. I also have 2 parallel lines, so I know that these alternate interior angles. See if these are parallel lines, these are alternate, that they're congruent. Now I have angle, angle, side. Angle, angle, side. Alright, this one says DEA. So I went across this and then up. Went across the 1 and then up. So over here I got to do the same thing, across the 1 and up. So it would be BEA. That BEA. Now I have this side and a 90-degree angle. So technically this one is called hypotenuse leg. It's not one of the shortcuts. It's one you see very rarely. If you have a 90-degree angle and one side marked, and it's kind of similar, you'll see hypotenuse leg. I didn't give it a shortcut because it is extremely rare. You won't have to worry about that. Okay, and then this last one, don't worry about that page. I was supposed to delete that one. Here's your extra credit. What I want you to do is simply do number 1, 2, 3, and 4. I want you to tell me, 1, are these congruent? So you'd be putting either yes or no as to being congruent. If you put yes, I want you to put which shortcut proves that they're congruent. You can put side, 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 angle, angle, side, side, angle, side, or angle, side, angle. It's one of those 4. Alright? Turn those 4 questions in and get your extra credit.